This video is a continuation of the ADS RFPro Smart Mount Basics that is currently available on the Keysight EEsof EDA Tips YouTube channel. We'll quickly review some of the key concepts of Smart Mount and then go into more detail about using the Smart Mount Instance Editor on in ADS layout window, and then dig deeper and look at how to set up the geometric alignment of the different layers in the structures that are being assembled. So the main concept of Smart Mount is to be able to assemble two structures from two different libraries and with different technology definitions. So the Smart Mount cell is assembled with a base cell. And the way this works is the two libraries, or the content of two libraries, can be assembled together. But then once this assembly is defined, then it can also be assembled on another library, which then becomes the base library, and so on. So this technology is actually able to assemble an arbitrary number of structures, and the challenge is that every time we assemble two structures, they are physically connected, and each structure has its own layers, and how these layers can be combined together. Basically, there's a lot of different combinations of this. So what do we need to define in order to be able to use a Smart Mount? First thing is, so there's actually a set of definitions for each library involved, and here I refer to Smart Mount library and base library. So the Smart Mount library is basically mounted on the base library. So let's start with the Smart Mount library. First thing is define the master substrate. So there could be several substrates defined in each library, but only one is actually used for this assembly. And I'll show later how to do that. Then for the substrate, we need to define which are the top and bottom interfaces, which are not necessarily the external ones. They can be also the internal ones if we want to assemble the two structures using one of the internal layers as the contact surface. Then we need to define how the substrate is, the orientation of the substrate. So it can be upside up, which is called bottom mount, or upside down, which is called flip chip. Then we need to define how the layers are aligned, so this is basically about the vertical alignment of the two, or more than two actually, contacting layers. And then lastly, define if there's any layer mapping involved. Now this is a complicated topic, but essentially if we want some shapes to be automatically created or defined on the base cell by the Smart Mount cell, then that's possible. And the typical use case for this was automatic definition of pads on the base cell, depending on how the Smart Mount cell is defined. So this would be typically when you want to mount a chip on a board or some other, it could be also a package, and you want these pads to be automatically created depending on how the chip pads are defined. But we will not get into this complicated topic that would require more time, so we will not will not cover this in the video. So these are definitions for the Smart Mount library. Now we also need to define the mount layer for the base library. This is defined at the cell instance level, and it defines what is the contact interface for the base cell. So let's start by seeing how to define the master substrate. So there's if you can see here the menu pick. So you go into the main window, you right click on the library. name, and then you get access to this technology edit master substrate menu, and this is so let's look at how we can define the master substrate. So there are several ways to get to this window here, but for example, you can go on the ADS main window, go to the library tab, and then select the library, right click on the library name, and then you get access to this technology edit master substrate menu pick, which opens this window, and this allows you to choose which substrate layer you want to define as the master substrate for this library. Once that happens, you can see that there's a red check mark here next to the selected substrate, and there's a master notation here within brackets here. Now, there is one more operation that is required at the substrate level for the Smart Mount library, which is defining which are the top and bottom interfaces, which will become the contact interfaces for when the Smart Mount cell is assembled with the base cell. So the way to do this, you click on the interface you want to select as the top or bottom interface, and then right click on this when you have selected the interface. You'll see the selection here, the two menu picks, set as top interface, set up as bottom interface. And once you select one of these, then you can notice that the interface will have thicker lines than, or a thick, let's say, black line outline compared with an interface that is not selected as top or bottom interface. Next, the Smart Mount library substrate needs to be defined, or the orientation needs to be defined, and there are two options, or two main options. One is bottom mount, and you see here in the case of the bottom mount, the mount bottom is in contact, or the interface to which the mount bottom is attached it gets in contact with the interface where base top is connected to. The other option is flip chip. So then in this case, the Smart Mount cell is flipped, and the mount top, in this case the mount top layer, or the interface where mount top layer is connected to, gets in contact with the interface where base top layer from the base cell is attached to. Now there is a general option which is multi-mount, and with selecting this option at the library level, then it will allow you to decide between bottom mount and flip chip orientation when each cell is instantiated. These settings are defined in this window here that you see, the nested technology window in the technology selections that I showed earlier, and as you see here, the Smart Mount subtype, this is where you can select multi-mount, bottom mount, or flip chip. There is an option here, which is this automatically use Smart Mount proxy P-cell for all designs in the library, which basically allows you to define a default for when checked for all elements in the library. In this case will be multi-mount. The other option is to uncheck this option and then be able to define the Smart Mount subtype when each cell is instantiated. Let's take a quick look at the Smart Mount instance editor. So the main purpose is to show the arrangement in this interface here, and I'll show you a quick demo later so you get a sense of how it works. but essentially it shows you in this case that the instance x3 is mounted on instance x2, and then which is mounted on the solder layer of whatever the base cell is in this case. Okay, so this is visually showing you the sort of the mounting hierarchy. Also, at the bottom here, there is two tabs here available. One is Edit Stacking. This one allows you to define which instance is being stacked. Or in this case, you have, since this one is already stacked, you also have an options to unstack. So selecting this one and hitting Apply is going to unstack the instance there. And this Edit Mounting tab for the selected instance contains the parameters, the mount subtype, which is going to be bottom mount or flip chip, and also the mount layer, and this will be the mount layer for the base layer in this case, and the base cell. So, and every time you select something, you need to hit Apply, and it will update the configuration. Another interesting feature here is that if you go into the Smart Mount Instance Editor and you hover over the selected specific instance, then you're gonna get the information on the stacking or the Smart Mount configuration and how it is stacked here as more specific. So I was going to show you what's the instance that is being this particular, for example, x3 is stacked on x2, and then it shows you the information on what on this instance and also on the mount layer. So in this case, the x3 is going to be mounted on the base. It's going to be the Smart Mount cell, which is mounted on the base cell x2, and this is the kind of the physical arrangement pictorially shown. So I'll show you an example how to use the Smart Mount Instance Editor here. So I'm starting from a pretty simple cell here. So you look at their two shapes on each of the two layers of the substrate here, and you can see how it looks like in RFPro. You see the 3D how the 3D arrangement. I'll just look at it from the side here. So then let's go and take and instantiate this cell. Let's just go one layer on top. As you see here, I've defined several different libraries, each one with a specific configuration of Smart Mount. You can see here, and we'll go through some of this later, but the automatic configuration, then you have the interface on top, layer on top. So these are the different alignment options here, but let's take this layer on top and then instantiate it here on the layout. And then it's going to ask me if I want bottom mount, flip chip, or custom. Let's go with bottom mount, and then let's instantiate it here in the middle. Then what happens here is then I can do a refresh now, and we can see how this is stacked. Now there's one thing I need to do here, which is to see this object that I have instantiated. It needs to be defined. The role needs to be defined as layout. Now there's videos that clarify what's going on here, but the important thing here is in this context is that we're able to visualize how the two are stacked together. Now I can also now if I go and look at the Smart Mount Instance Editor here, I can see there's information on this is a bottom mount, base top. But it's not particularly interesting in this case because it's essentially it's being stacked on the using the mount layer on the base top on the base cell. But it gets more interesting here if I instantiate one more instance of this cell here, and then as you see here there are two instances, and Now I can hit refresh and see how they're actually connected. So you see this. Basically there are two. The two instances are placed on the same. They're basically overlapping. Now what I can do is I can take x2 here, and now if I go instance stacking, now I can decide to stack it on x1. So I hit apply. And you see here, there's an indentation here. It shows you the hierarchy. By the way, it shows you also as I'm hovering over the instance here, you can see what's more information. Now I can go here and refresh in RFPro. And at this point, you see that that's how the two instances are stacked on top of one another. And now I can go to edit mounting here. And if I want to, for example, flip it, I can do this. I can hit apply, and then now when I refresh, the top instance is flipped. It becomes flip chip configuration here. If I want to unstack x2, I can select it here, go to edit stacking, select the not stacked option. Now you need to remember to hit apply, and now as you see here, it's not indented anymore. And if I go back to and refresh here, then it will overlap again here. And by the way, it's one of them is it's in flip chip configuration, and I can put it back on bottom mount, apply, and hit refresh, and you see there are two instances actually here. They're overlapping one another. Let's take a look now at how to align layers in this smart mount operation. So go back to one of the earlier slides and focus on the last 2 points here. So we're going to see how the two structures are assembled, the different ways we can arrange the layers on the contact surface between the two structures, and some of the combinations that are possible here in this assembly operation. So if you look at the menu here, the nested technology menu here, or window, you can open by right-clicking on the library name, and then going to technology, and then selecting nested technology. You see here that there are the different options. This is where different smart mount options are defined. And we've seen already the subtype. We'll talk a little bit about this option here, which is currently unchecked. This is how you define the chip alignment option by default. And if you see here this question mark, this is how you actually access the information on the different combination, different alignment options. And we'll see there are several of them documented, but this is, if you click here, then you get access to the documentation here, the section of documentation that explains the different options. And here you can see the two main pages, one for bottom mount and the next one is for flip chip. So this slide should help you better understand the pictures contained in the two tables that we just seen. So there's the smart mount library called the chip library, is represented in the orange, and you can see here there's interface. This is what represents the interface, and this is what represents the layer. So this will help understand how interface on top or layer on top options work. Whereas the base library, which is referred to as board, is represented by this blue block, and this is the mount layer that you see here. The parts is sticking out, and this is the mount layer interface. So the interface the mount layer is attached to. Then in the documentation, you'll see that there's this reference to chip bottom and board top. Now, given that everything can be flipped around, Now, this is, I would say, is not to be taken literally. This essentially means the layer that is sticking out of the contact interface from on the chip side or on the smart mount library side. And this is the layer that is sticking out of the contact interface on the base library side, which is referred to as board. So we'll see how this, different combinations, many different combinations exist, but this hopefully will help clarify what we're going to show later. So let's look at a couple of specific examples. So this is the full automatic mode of Smart Mount. So to use this mode, essentially you check this Map Layer and Align option. And let's see what happens. So there are two situations here. One is where the conductor layer on the chip bottom interface is intrude or and below interface or sheet, and this would be the situation shown here, where the mount bottom layer kind of sticks out of the substrate here. Whereas the other situation is where the conductor layer and the chip's bottom interface is intrude and above interface, which is the one you see here. Now, what is shown here is how these two layers are assembled. So, and you see they look almost identical except for this orange line here sticking out, which essentially means that in this case, this is the contact interface on the chip side, and this is the contact interface on the board side. And what sticks out here is board top. And also, you see here chip bottom, but actually what happens is the chip bottom layer, so this mount bottom layer basically doesn't exist anymore. But there's still the space here between the two contact interfaces is maintained. Whereas in this other case, the board top and chip bottom, they look the same. Essentially, chip bottom goes away, but the contact interface on the board side is at the same level as the contact interface on the chip side. This is how it looks in RFPro. So you'll see that the top layer of the base library is there in both cases. You'll see that the bottom layer of the chip, so the smart mount cell, went away in both cases. But in one of the two cases, the bottom, the contact interface on the chip side, it sits on the top of the metal, of the top metal of the board side, or the base side. Whereas in this case, the contact interface of the chip or smart mount cell, it sits on it's aligned with the contact interface of the base. So this is essentially how in reality it looks like, and so hopefully this will help you interpret the symbols in the documentation. Let's now look at manual mode. To get this mode, first thing is unchecking or making sure this box is unchecked, Map Layer and Align. Still referring to the documentation, we'll look at it at a few cases here. So let's get the situation where we're in a bottom mount, and then in the intrude and below interface substrate configuration. So we'll see what that means, and then we'll look at the difference in behavior between chip on top or interface on top. As a matter of fact, chip on top, it actually refers to the layer on top menu there, and so this is a typo. So what are the geometries here? So we have the chip here with mount top and mount bottom, and then we have the board with base bottom, which we're not going to use. In this case, we're just going to use base top, which is defined as the mount layer. And the other situation here is where we're going to have the interface on top. And we'll see how this geometry is actually generated later in RFPro. We'll see a live example. But if you read here, it says the bottom of a conductor layer on the chip bottom interface. So this would be this surface here. The bottom of the conductor layer on the chip bottom interface aligns with the top of the mount layer. This is the mount layer. The top of the mount layer will be this interface. So you put the 2 and 2 together, this surface here will touch this surface here and generate this type of alignment. Now, interface on top, so in this case, there's going to be instead of this surface here is going to be the interface that's going to align. So in this case, bottom interface of the chip, which is this, aligns with top of the mount layer. And again, the mount layer in this case is the top of this base top layer, which happens to be the mount layer. That's why essentially the mount bottom layer intrudes into the base top layer of the base here. Let's now look at a similar situation, or same thing. We're in bottom mount, but the substrate configuration or the layer is intrude and above interface. So we're going to look at both a layer on top alignment and interface on top alignment. So like we did before, let's read here. It says the bottom, so you're in the layer on top alignment. So the bottom of the conductor layer on the chip's bottom interface. So in this case is the bottom of the conductor layer on the chip's bottom interface, which is this surface here, aligns with the top of the mount layer. The mount layer is this one, and the top interface, the top of the mount layer is this surface here. And so this surface here aligns with the top, with the surface here, and it gives you this picture here. Now, interface on top, it's well, instead of the bottom of the conductor layer, we're gonna interface. We're gonna use this as interface, which are basically the same place. So this interface actually doesn't have any thickness. So the bottom of this layer here is exactly the same as this interface. So that's why when we align this with the top of the mount layer, well, it gives us exactly the same thing. Let's now go back to the previous case, which is the intrude and below interface, and let's see how that looks in RFPro. On the left side, there is the layer on top configuration. As you see here, the bottom of the conductor layer of the mounted cell connects to the top of the mount layer of the base cell. Whereas on the left side, we have the interface of the mounting of the smart mount cell here connects with the top of the mount layer of the base cell. Now we can also see, now the question is this metal still there? We don't see it. Now if we go under substrate conductor and we click on mount bottom, then we can actually highlight it and see that the layer is indeed still there. So to recap this last part, and going back to this section of the documentation of all the different cases that are described there, we basically covered these 6 different cases, and this is just for bottom mount. There's also the part that concerns the flip chip, so there's an additional configurations there. Now, hopefully with the additional detail that has been provided in this video, you're able to interpret, to better interpret these tables here and figure out, looking at them, looking at the alignments here, the different situations, which one fits your needs, and you can at this point hopefully easily implement it in the libraries and be able to assemble the structures the way you want. So hope you found this video informative. Well, have fun with SmartMount.